Yes, good morning class. This is once again Tr.Amagu Alex taking you through physics. And before we introduce our lesson today, let's attempt this short starter question to review our previous lesson. And our starter question reads, state any three optical instruments you know. And this is a question which takes just around 3 minutes, and I do expect all the learners to attempt it in their individual books, and after this we are going to exchange our books as we assess ourselves. As the question reads, state any three optical instruments you know. And whoever has done, you can just exchange your book with your neighbor and we see how to assess ourselves. Okay, 2 minutes are remaining. Okay, 1 minute to go. Some few seconds. Here we go. Now I hope we have all exchanged our books. Can we give our books to our neighbors and pick the one of your neighbor? And as we are going to assess, where you see a right score, you give a neat tick. These are the possible responses. If you are told any of your colleague has one of these responses, mark it right. The first response is camera. If any of your colleagues have that response, mark it right. Okay, the second one is magnifying glass, or someone can write a lens. Okay, that's good. We move. Next one, if someone has human eye, you also mark it right. Then another one is projector. Then we say etc. etc. Since the question only requires for 3, you can just select any 3. Then you award the score. So let's go to the scale on the score. So if a friend scores 3 out of 3, write 3 out of 3, then you give a comment of gold. And if a friend has 2 out of 3, you give a comment silver. And if a friend has 1 out of 3, you give bronze. Yes, someone is going to ask what about 0 out of 3. So long as the person has written something, give him or her bronze. Thank you. So we are moving ahead. Okay, thank you very much, class. You can give the books to the owners. And also that one is leading us to our next lesson. Now our next topic today. And we are still under the theme of light, and since we said light is a wide theme, so today specifically we are going to look at the topic of image formation by a converging or convex lens. And like last time, when we were looking at the type of the lenses, but here mainly we shall look at a convex lens today. Now, our learning outcomes, we mainly have the 3 learning outcomes in this lesson. I do expect by the end of this lesson that we shall be able to draw accurate ray diagrams. 2, we should be able to identify and describe the characteristics of the images formed by the convex lens. Then 3, we should be able to relate the ray behavior to real-life devices such as camera, magnifying glasses, microscopes, and the human eye, and etc. etc. When you look at these items, these are the items which we have stated in our above starter, and that's why we are saying that this is the core of our lesson today. So, as also we are going to dive in this lesson, our main attention here is about the refraction of light in convex, and that's what we are going to learn mainly today, and it is what is going to guide us, and it is going to take us through our topic today. So if okay, like what I had said, we are going to look at the convex lens, and convex lens is the type of the lens which is thicker in the middle, and the diagram which I'm trying to draw here on this flip chart, it is illustrating how a convex lens looks like. So from this, we should be able to identify the key terms which are applied in the convex lens. One, you are looking at that letter C, it is what we call optical center of the convex lens, and we have F on the both sides, which I'm trying to illustrate here using the marker pen, on my right hand side and another one on my left hand side. When you look at this, the distance of F to C, or to the center, or to the optical center, they are equal. And down here, you will realize that there is a distance which is from that point F to the center C, and all of them are indicated with a small f. So these are the keywords which we are going to look at here. The C, we have talked that it is what we call the optical center of the lens, and the F, which are the capital F, we call them as the principal focus, or some people call it as the focal point. Then, when we look at these small f's, we call them as the focal length, or someone calls it as the distance from the principal focus to the center of the lens, or we call it as the optical center. So I'm trying to illustrate this, and also these are the key terms which we shall look at in our lens. Now, like what I was explaining, if at all we go ahead, so I'm there trying to also write what we call the principal axis. The principal axis is this horizontal line which divides this lens into two equal parts, the upper part and the lower part. That horizontal line, we call it as the principal axis. Then, the next key term which we are going to look at here is, sorry a bit. So I'm still trying to illustrate this. So if at all we move ahead, this F, which is the small f, and also we call that as sorry about that, as a small f, so we call it as principal focus. So if you can go ahead, so we shall realize that when we are dealing with the lenses, mainly this convex lens, we are applying mainly some three key rules which we shall use in also developing what we call the accurate ray diagram. So I'm going to take us through these three key rules, so which we shall in turn use them to also develop our accurate ray diagrams. So out of these three rules, Rule number 1, we are going to look at how a ray which is parallel from the principal axis, or if at all you have an object and there is a ray which is parallel to the principal axis, which is moving horizontally, and once it meets this lens, and once it meets the lens, it will be refracted through the also principal focus on the other right hand side. So which I'm here trying to illustrate. So rule number 1, we say rays parallel to the principal axis are refracted through F. So if you have the lens, which is represented by the dotted line, and yes, and the shape of the convex lens, and I have the horizontal line, that's my also principal axis. Then I draw the two F's on also both sides, that is the principal focus. Now if at all I have a ray which is parallel to this principal axis, which is like this, then whereby it will be refracted through so this other F, which is on my right hand side. So that's rule number 1. So that's how I'm here illustrating it, and I hope you are able to see it on my flip chart. Then we go to rule number 2. Rule number 2 is almost the opposite of rule number 1. So rule number 1, we say that the rays parallel to the principal axis are refracted through the focal point or through the principal focus. So the opposite is going to be, is there someone who can tell us the opposite of this? Yeah, Benjamin is raising his hand up. Thank you very much for that initiative to try. Now, when we look at rule number 2, we are going to talk about a ray that is passing through F. As I was saying, it is the opposite of rule number 1. The ray that is from the object and is passing through F. After meeting the lens, it will be refracted parallel to the principal axis. It will be refracted parallel to the principal axis. Then, if at all you also look at my illustration, you will realize that it is the same way what I have said. Rays passing through F are refracted parallel to the principal axis. So you can look at my simple illustration of this rule number 2, whereby I draw my principal axis and the lens, then the shape of the convex lens, then I have the two F, one on the left hand side and one on the right hand side, which are representing principal focus. Then if on my left hand side there is a ray which is passing through F, meeting the lens, and after meeting the lens, and it will be refracted parallel to the principal axis, meaning it will be horizontally like the way my principal axis is. And mind you, when we are presenting the ray diagrams, we always indicate the direction of the movement of the light ray, that is by an arrow. And always when we are drawing this, however much I'm just illustrating it using a free hand, but when you are going to illustrate yours, make sure that you use a ruler and a pencil and you draw an accurate ray diagram. That's why the word is accurate ray diagram. Now we are going to go to rule number 3. Rule number 3 is, when we were in senior 1, when we are looking at the law of the reversibility of light, we say that the light takes its own path when it is being refracted in a straight line. And this is the rule number 3, which summarizes almost that rule. So here we are saying rays passing through the optical center C of the lens continues in a straight line, or it is undeviated, or it takes its own path. So whereby when you have a ray just passing through that optical center, yes, I'm trying to illustrate. I have what? That's good. The C is there, so whereby I have this ray which is passing through that optical center, and it will go undeviated, or it will trace its own self, or it will move in a straight line. So those are the 3 rules which we shall use to guide ourselves when we are going to draw the ray diagrams here. So these ray diagrams which we are going to represent today, it is what is going to guide us when we are going to locate the image of these objects, which are at different positions in front of mainly convex lens. So like the way I had said with you, so the various positions of these images can be located, and also we shall use any of these 2 rules which we have talked about. We may not use all of them, but we shall only use any 2 of them. But where the 2 refracted rays meet, it will give us the position of the image. So I'm here talking about how do we locate an image through a lens. And which type of the lens are we here looking at today? We are looking at a convex lens. So number 1, we are saying that any 2 rules can be used here. So we shall not use all the 3 rules, but I just want us to just use any 2 of them. So like what I have said, any 2 rules here can be guiding us to locate where this image can be formed. And it is what we are going to look at today. So 2, when we are finding the intersection point and where these 2 refracted rays are meeting, that is the exact point where the head, where the image is formed. We shall not look at where, so the bottom, where the 2 refracted rays are meeting or are intersecting is the exact point where our image is going to be formed. Is it clear? Are we okay there? And as I said, these are the key points in whatever we are going to do here. It is what we shall follow. And once something is not clear, please members, feel free and ask, because it's the right time for you to understand something, because after this we are going to have some time to interact in our groups, and we shall share more experience in our groups, because I do understand that some of you know these things. However much someone may be saying, oh what, but I do believe when you share it in your groups, it's the best experience that we can learn. So under this number 2, how can we find this image? So we're saying 1, where the 2 refracted rays meet gives the position of the image, and this image can either be real or it can be virtual. But here we're saying that image is infinite This one, infinite, means that something which is formed at a distance, or it is formed at a very far distance from the lens. But we shall look at some situations where you realize that these refracted rays are not meeting near, they will be meeting very far. And also a case point, we shall look at some also gadgets which are used by the security team, and whereby we say that they are able to see their enemies at a distance. Then when we look at what we call virtual image. Virtual image is the type of the image which is formed by the intersection of imaginary rays. Now, number one, when the object is between the F and C, F, we said it is the principal focus, and C is the optical center. Now, when you have the object O, which is between the C and the F, like the way I have illustrated it there, we shall apply any two rules. Now, rule number 3, which you said a ray from an object passing through center C, or the optical center, this line is undeviated. And our rule number 1, which was a ray parallel from the object to the principal axis, is refracted through the principal focus. Now, when you look at where these images are, you realize that these images are formed by the imaginary, or by the assumption of the rays which were passing through, or which were coming from a certain point. Now, when we try to maybe extend these rays, so whereby our also ray which is passing through F, we shall prolong it with that dotted line, and also this other ray which was passing through F, we shall prolong it that way. Now, where the two dotted lines meet, that's where our image is formed. And also when you look at the nature of the image, and I was saying, when I was explaining something, when two refracted rays meet, that gives you the position of the image. And here, let's be keen enough, what type of the rays are meeting. So we shall realize that these are imaginary rays, or these are dotted rays, or something which is imagined to be meeting, and that's why they are dotted. And when we come to the description of the characteristics, the properties, the nature of the image being formed, our image I, so we shall look at which type of the rays have formed this, or have met. So we shall look at the intersection. So obviously, since they are dotted, I have talked about a virtual image, and that's why we say that this image I is a virtual image, because it is formed by the intersection, or by meeting of virtual or imaginary light rays. That's the reason why we are saying it is a virtual. Number 2, this image is formed between the two F and F. In other words, where is this image being formed? That's now where we're now talking about the position. So we're saying it is formed between the two F and F. When we are looking at mirrors in scenario 2, we say that position 2F is what we are calling as the center of curvature. But when we are looking at the lens, we shall call it as 2F. Now, another property of this image, when we try to compare the height of the image in relation to the height of the object, you will realize that this image is taller, or it's bigger than the object, and we can describe that as the image is magnified. assuming it was smaller than the object itself, and which I hope we shall meet in other also examples where the object is in another location. So we should take keen attention here, and when we also describe this nature, when you talk about virtual, what is the opposite of virtual? We should know that. If you say it is magnified, what is the opposite of that? And another property which we can talk about here is that this image is upright, or some people say it is erect. It is standing upright, facing upwards, not facing downwards or what. So we shall also look at some cases where the image is going to face upside down, and then we shall also describe that with the opposite of the word upright, which is going to be inverted. But this particular position where the object is between F and C, we say the image is virtual. It is between 2F and F. Now the image is magnified, and lastly we say the image is upright. Members, are we clear there? Wow, that's why I like this class. It is a really an active class. Is there any question here? Is there something which you have not understood here? Thank you. So otherwise, we are going to go to the next part, but I'm here trying to emphasize on these words. And since, according to also my lesson plan which I had said, I'm just trying to illustrate for you the first example, then I will also leave you to also share more, to also come up with the other, other location of the position of the image. So what if this object is in another location? It is what we are going to look at in our next 10 minutes. So members, I'm going to group you like the way I have said. At least each group should present something, but like the way I have said, our Google Sheet is there for each group, where I have designed it in such a way that in each group, once you are going to look at where the object is placed. Now, since I have looked at where it is between the F and C, I'm going to ask you, where will the image be formed when this object is beyond, or it is after 2F. Now after that, if it is after 2F, now next I want you to begin with this. When the object is at F, where can the image be formed? And here I have just started with the two rules.